Today's lecture concerns averages, but before we do so, I would like to take a moment to share a quote from Warren Buffett. It takes 20 years to build a reputation and 5 minutes to ruin it. If you think about that, you'll do things differently. So if you like that quote, let me know, share it with someone, but I definitely enjoyed presenting that to you today. So do think about that. Think about that. Today, averages will entail 4 averages called the mean, the median, the mode, and the mid-range. At the end of the lecture, I will speak about a 5th type of average called the weighted average. So all in all, there are 5 averages in Chapter 3. Remember, after the lecture on averages, we then will move to the measures of variation, standard deviation, and finally, measurements of position. For each section, I will be showing you 3 examples: raw, ungrouped, and grouped. It's very important that you know the type of problem that you are dealing with so that you know how to work it out by hand, if you choose, or use the calculator. I will review 2 definitions before we begin. A statistic is any measurement taken from a sample, but a parameter is any measurement taken from a population. A frequency distribution table organizes raw data into table form. When you see a table, the problem will either be ungrouped or grouped. Basically, a table will consist of a X column and a frequency column if it is ungrouped. A table will consist of a class boundary column and a frequency column if it is grouped. Now, raw data is a string of data values separated by commas. The data can be in increasing order or it can be out of order, but it is a string of data values with or without order. You could also list raw data in column form without the commas. Again, it can be in order or out of order. The table gives us a way to organize the raw data. Therefore, we have ungrouped data problems and grouped data problems. For the entire chapter, you will follow one rounding rule. And the rounding rule says when we calculate our measurements to compare the raw data values X, and you'll find out that sometimes we have to compare to the midpoints. And when we look at the raw data values or the midpoints of a data set, we round the mean, the median, the mode, the mid-range, the range, the variance, and the standard deviation to just one additional decimal place. So if your raw data values are whole numbers, as in this example, and we find the mean, we will round the mean, if necessary, to the nearest tenth, which is one additional decimal place. And again, the rounding rule applies to the entire chapter. So let us begin. Page 2 of the lectures. And again, I'll remind you that this lecture is on Blackboard if you would like to print it off. I'm going to go into greater detail and explain what I have written. The average column, mean, median, mode, and mid-range, are the 4 most important averages. And when we speak about these averages, sometimes they use the terminology measures of central tendency. And they're all averages, but they do have different definitions and formulas. With these averages, every single data value carries the same weight. So when we speak about weighted averages at the end of the section, with weighted averages, the data values carry different weights. That is why weighted average is not included in this category. Now, a statistic versus a parameter. Remember, we work with samples unless told otherwise. So the sample mean is X bar, the sample median is M sub D, Sample mode is MO, and sample mid-range is M sub R. Population mean is mu, and that is a Greek letter. Population median is capital M, capital D. Population mode is MO, capital. And population mid-range is MR, capital letters. Again, we work with these symbols most of the time because we work with samples unless otherwise told. The first example is of a raw data problem, and I take 5 women working at the same law firm. If you notice, their ages are not in any particular order. They're out of order, actually, and they are separated by commas. I wish for us to find the sample mean, median, mode, and mid-range together, treating it as a raw data problem, and then I will show you how to use your calculator. If it is the sample mean, you will use the formula x bar equals the summation of x divided by n. This is also the definition of what it means to be a mean, a sample mean. It is the sum of all the data values in the set, and I let x represent the data, divided by the sample size, which is the lowercase n. Sample size is the number of data values that you have, and we have 5 ages, 5 women, 5 ages, 5 pieces of raw data. So I add up all of their ages and divide by 5. And 37.6 is the exact answer. No rounding was necessary in this case. Now, the median. With the median, the definition is the data value that falls in the middle of a data set, but only after you put the data in increasing order. So I'm going to have to list the youngest lady to the oldest lady, 28, 30, 36, 44, and 50. Since this is a very small data set, I think that it's very easy for you to see that the median, the data value falling in the middle, would be the 36-year-old. So that's the median. But it's not always easy to see the data value that falls in the middle, especially when we have a very large data set. So there is a process. Calculate n divided by 2, which is sample size over 2. I like to call this a locator formula to help us locate the data value that would be the median. If you have a number that is not whole, in this case it's 2.5. It's not a whole number. The textbook says to round up, and 2.5 will round to 3. So we go to the third member in the data array, 1, 2, 3. And that third member or third lady is 36 years old. Hence the median is 36 years old. Now if n over 2 is not whole, you round up to the nearest whole number and go directly to that member. So there is your rule for this situation. If n over 2 is not whole, round up to the nearest whole number and go directly to that member in the data set. But remember, put your data in increasing order if it is not already in increasing order. That is very important. So, I want to show you like a side example because you need to know how to handle the case when n over 2 is whole. It says to go to the members n over 2 and n over 2 plus 1 and average them together. So that means if n over 2 is whole, go to that member and go to the one right beside it and average those 2 members together. Here is a side example. This is not the original problem of the 5 women. I decided to throw in an extra lady and make her 32. 28, 30, 32, 36, 44, and 50. We now have 6 ladies. 6 divided by 2 is a whole number 3. So we would go to the third lady and the fourth lady and average their ages. The third lady is 32. The fourth lady is 36. So when you average their ages, you have 34 years old for the median. Now, the mode is the data value that occurs most frequently. You can have no mode, one mode, or several modes. In this case of the original 5 women, the mode is none. They all occur just one time. Now, I have some side examples. Suppose we have 6 women here, but now we have 2 36-year-old women, and the other women, 44, 50, 28, and 30, they all occur one time, but the 36-year-old, I have 2 women that are 36, so the mode is 36. Now I have 7 women. I have a 36 here and here, a 44, one 50-year-old, one 28-year-old, and one 30. So the mode is the 36 and the 44-year-old woman because they each occur twice. And then here's another example of when you would have no mode. Let's suppose I have 2 36s, 2 44s, 2 50s, 2 28s, and 2 30s. They all occur twice. Same level of frequency. So there is no mode in that example. So no mode, one mode, several modes. The last and final average with respect to raw data is the mid-range. The mid-range is the smallest data value in a set plus the largest value in a set divided by 2. So it's the average of the smallest and largest. The youngest lady was 28, the oldest lady was 50, and their ages added together, 78 divided by 2, 39 years old. So now I wish to show you how to put the raw data problem into the calculator. In order to do so, I'm going to go back to the original data set, which is from page 2 of the lecture notes, and I'm going to put these values into the calculator. Before I do that, I would like to show you the calculator. This is a TI-83 Plus. I have 3 calculators. I have a TI-83 Plus. I own a TI-84 Plus Silver Edition. And my most recent calculator is a TI-84 Plus Edition, but it also has color options with the screen. So I'm excited about using that in class. For the TI-83 and the 84, they all have the stat button. Now with my 84, my second button may be blue. In this case with the TI-83, my second button is yellow. Everything that you see that is in yellow, if you wish to obtain it, you will have to press second before you can obtain what you see in yellow. So we will use list above the stat button. So in order to obtain it, we will have to press second stat. Now I'm going to press stat so that you can see the window. You have edit, calculate, and test options. Now to maneuver inside the window, I use these 4 arrows, up and down, left and right. The other area that I like to use to call up columns, my L1, L2, L3, 4, 5, and 6. In order to access those columns, you can see with the 83 it's in yellow, so I would have to press second, number 1, second, number 2 to call up those columns. Sometimes you have to use the comma button and these 2 parentheses, and they are keys, so you can just press those. The other area that I'll show you is second stat, which will show you your other options. If you do second stat, you can call up the columns from here. If you arrow over to math, you can actually just give the mean, the median, the standard deviation, or the variance of a data set if you wish. I am going to go back to the stat button, and you can see that it's highlighted here. Edit. And I am going to, with edit, press enter. You will see that I already have data in L1 and L2, and I would like to clear those lists. There are two ways to clear a list. I will show you the way that I use most commonly. I go to Stat, and I arrow down to number 4 and press Enter. The cursor is blinking, asking us which list to delete. And what I do is call up the column. Remember, you could call up the column from Second, Stat, which is the list menu, or you can call up the column from below, Second, number 1. I like to do Second, number 1, just because that is what I am used to. And then you press Enter. It will say Done. So that when you go back to Stat under Edit and press Enter, you will see that the L1 column is clear of entries. The other way to clear out a column is to take your cursor and arrow over. Your cursor has to be, for example, highlighting L2. Once you highlight L2, then you are saying that that is the column that you wish to clear. Be very careful. You do not want to delete the entire column called L2. You just wish to delete the entries. So here we go. What you will do is you will press your clear button, which is here. So clear. And this is what your window looks like. Once you press your clear button, the only additional button that you press is the down button. So I'm going to do it. Down. So clear and down. Clear and down. I think that most students will choose this option for clearing columns because it is quicker. So I'm going over to L1, 36, Enter, 44, Enter, and let me go back. 36, Enter, 44, Enter, 50, Enter, 28, Enter, and 30, Enter. I like to scroll up and down and make sure that all of the entries are correct. One wrong number will throw off your calculations. Once you have your data in the calculator successfully, and this is what a raw data problem would look like in the calculator. Stat. Arrow over to Calculate. One variable statistics is where you're going to go. It's already highlighted there, so press Enter. Again, the cursor is blinking, where's your data? And you wish to call up column L1. So I will do that. And then press Enter. You will see that your sample mean is exactly 37.6 years old. No rounding was necessary. The summation of all the ages was 188. The S sub x is standard deviation, and we are not ready for that, but in one of the sections we will learn standard deviation. Scroll down, and MED is going to be the median of 36 years old. So you want to look on the calculator for MED for your median. Don't forget about Second Stat, which is the list menu. If I only ask you for the mean, and that's all you care about for a data set, and you do not wish to see the standard deviation and the median, then you would go to Second Stat, which is the list menu, arrow over to Math, and go to number 3. Press Enter. Again, call up column L1 if your data is in L1. And close that in parentheses. Remember, your parentheses are located here. So, parentheses, and press Enter. The mean is 37.6. So, on to example number 2. For example number 2, I wish to show you an example of ungrouped data. The following number of textbooks were read by each of 19 students in an English class. Find all 4 sample averages. I will say that if this problem is given to you on a test, you will be given the descriptive paragraph, and you will also be given the X column and the frequency column. The X column gives us the different types of data values, and the frequency column gives us the number of times in which they occur. So I am going to pause here for just a moment and log back into the computer. It has seemed to log me out, so I will pause and come back to the ungrouped example. Sorry about that. So this is 19 students in an English class. And this says that 2 of my students read no textbooks, 3 students read 1 student read 2, 5 students read 3 textbooks, and 8 students read 4 textbooks here. And the total of the frequency column will always give you your sample size. So we have 19 students and the number of textbooks that they read. So you will be given the X column and the frequency column. Now let me begin to show you how to find the mean, the median, the mode, and the mid-range. For the mean, you will need a column called F times X. The purpose of this column is to add up all 19 pieces of data. Let me explain. This is an ungrouped example, which is a frequency distribution table, an X column and a frequency column. You could technically list the raw data out for this problem, saying that 2 students, the first student and the second student, read 0 textbooks. And then the next 3 students read 1 textbook. And then 1 student read 2 textbooks. 5 students read 3 textbooks. And the final 8 students in the class all read 4 textbooks. So you can list out all 19 pieces of data, and the data does represent the number of textbooks read. So the F times X column is a quicker way of finding the total of these raw data values. And so it is simply 0 times 2 is 0, 1 times 3 is 3, 2 times 1 is 2, 3 times 5 is 15, 4 times 8 is 32. When you add up this column, you have the summation of frequency times X column, which is 52. If you took the time to add up all the raw data for this problem, you would receive 52. So this summation is important for the mean. So for the mean, we will take the formula, the summation of F times X divided by N, which is the summation of the data divided by 19, the sample size, and we get 2.7 textbooks. Now, if you can see this, rounding is necessary, and I will show you on the calculator. 52 divided by 19 is equal to 2.736. Remember the rounding rule. If your raw data values or your X column happen to be whole, you will go 1 additional decimal place. So correctly rounded, it should be 2.7 textbooks. So that is an approximate answer following the rounding rules. Now the median is a little bit more difficult for an ungrouped data problem. First thing you could do is use your locator formula. You will not have to worry about your data in increasing order. The smallest number of textbooks read is 0 and the largest number is 4. And if you list all of these out for the 19 students, 0, 1, 2, 3, 4, they will be in increasing order. However, you still need the locator formula. 19 halves is 9.5. Since it's not a whole number, the textbook says to go and round up, so we need to locate the 10th member. Now, if you actually took the time to write out the raw data for the 19 students, you could count over. 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, and 10th student. The 10th student, representing the 10th member of the data set, reads 3 textbooks. So the median is 3. This is not always easy to do if you have a large data set. So this is what you'll need. A cumulative frequency column helps to locate the median by hand. This is how you construct. Always bring the first frequency over. 2 is brought over. To receive the rest of the numbers, add diagonally. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 5 is 11. 11 plus 8 is 19. The last value in the column should be your sample size. If it is not, you did something wrong. So, the actual construction is simple, but here is the interpretation. And I will say this slowly. This 2 means that my first 2 students or my first 2 data values are 0 textbooks read. And you can see that here. This 5 means that my 3rd, 4th, and 5th data value, or my 3rd, 4th, and 5th student, all read 1 textbook. And you can see that down here. This 6 means that the 6th student or 6th value alone in the set is 2. So the 6th student read 2 textbooks. This 11 means that the 7th, 8th, 9th, 10th, and 11th student or value is 3 textbooks. And you can see that here. The 19 means that the 12th through the 19th student, or the 12th value in the set through the 19th value in the set, are all 4 textbooks read. And those are the last 8 students in the class. So the 10th member is here, because this represents members 7 through 11, the 7th student through the 11th student, all read 3 textbooks. And you can see that here. So the median is again 3. If you understand the interpretation of the cumulative frequency column, you will be able to see where the member will fall. But always refer to the X column to actually give the median. The median would not be 10, it would not be 11, but the 10th member falls here, so it is 3. 3 textbooks read by the 10th student. So, the next value is the mode. The mode is the data value that occurs most frequently. And you can see by the frequency column that 8 students read 4 textbooks. So 4 textbooks is the data value that occurs most frequently. So the mode is 4. And you can also see that in the raw data set below. The mid-range is the smallest data value plus the largest divided by 2. The smallest number of textbooks read is 0, and the largest number of textbooks read is 4. So if you average those together, you receive 2 textbooks. Now, the group data problem. I'm going to show you the mean, the median, the mode, and the mid-range for the group data problem. This is 80 light bulbs, or 80 pieces of data in the data set, and their endurance times. How long do they last? Find all 4 averages and assume you don't know the original number of hours that the 80 light bulbs actually last. So this is why this is grouped. We have a column called class boundaries in terms of hours. We do not have a X column. So the first 6 light bulbs, they endure somewhere between 52.5 and 63.5. But we don't know their actual individual endurance times. The next 12 light bulbs out of the 80 fall here in terms of time. The next 25 here. The next 18 here. 14 here. And the last 5 light bulbs fall here. The total of the frequency column better give you 80 pieces of data. So the size of this data set again is 80. 80 light bulbs have 80 endurance times, which we don't know, but we do know where their times fall approximately. This class boundary column would help you form a histogram, and these boundaries would be on what we would call the x-axis, and they will be touching each other because you can see that they overlap, and the width of each rectangle will be exactly the same. The height of the rectangle would be found using the frequency, using the y-axis. So the y-axis and the frequency axis would be the same, and these are the heights of those rectangles. Now, to find the mean, since we do not know x, we will use the midpoint. X sub m is the midpoint of a class. And I will show you how to calculate the midpoint column. The midpoint column is calculated from the formula, the lower bound or limit of a class plus the upper limit or bound of a class divided by 2. So the first class has a midpoint of 58. And what do I mean by lower bound and upper bound? We have 5 classes. 6 classes. Therefore, we would have 6 rectangles in the histogram. The first class goes from 52.5 to 63.5. The lower limit or boundary is 52.5 all the way to the upper limit or boundary, which is 63.5. If you average these two together, which means to add them up and then divide by 2, you will see that 58 is exactly between them. And you would have to go through that formula 6 times. 63.5 plus 74.5 divided by 2 is 69. Etc., 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 etc. Now, either you could use the midpoint formula 6 different times for the 6 different classes, or you could use the following trick. The class width, or the width of a rectangle, is the positive difference between any 2 consecutive lower limits or bounds. So these are 2 consecutive lower limits. It is also the positive difference between any 2 consecutive upper limits or upper bounds. No matter which 2 consecutive lower limits we take, the positive difference is always the same. No matter what 2 consecutive upper limits or bounds we take, the difference is always the same. And so the class width is going to be 11. 58 plus 11 is 69. Plus 11 is 80. Plus 11 is 91. Plus 11 is 102. Plus 11 is 113. So if you find the first midpoint by averaging the 52.5 and the 63.5, and you know your class width, you could just add the class width each time to receive your midpoints. Now, since we don't know the x's, the midpoints will represent the 80 light bulbs. So 6 light bulbs endure about 58 hours. The last 5 light bulbs endure 113 hours. So we will not need the total of the x's, but we'll need the total of the midpoints. Therefore, we need a f times midpoint column. Be very careful. 6 times 58, these are large numbers. 12 times 69, 25 times 80, 18 times 91, 14 times 102. 5 times 113 is 565. The sum of all 80 midpoints would be 6,807. Therefore, the mean is going to be the sum of the midpoints divided by the sample size. And that is going to be 85.1 hours. You will need to round to the nearest tenth. Even though we do not know x, we know the midpoint. So the rounding rule says go to x or go to the midpoint, take a look at it, and if you have to round the mean, the median, the mode, the variance, standard deviation, go to 1 additional decimal place. So we will round to the nearest tenth in this case because my midpoints are whole numbers. And that is accurately to 85.1. The median says that we have to find the midpoint that falls in the middle of a data set. And that's going to be the locator 80 over 2. So we have to locate the 40th and 41st midpoints and average those midpoints together to receive our median. So the cumulative frequency column will come in handy. First, you will bring over the 6. And then 6 plus 12 is 18. 18 plus 25 is 43. 43 plus 18 is 61. 61 plus 14 is 75. And 75 plus 5 is 80. And the last value is the sample size. This means that my first 6 midpoints, or values in the data set, midpoints, are all 58 hours. So those first 6 light bulbs. This 18 means that light bulb 7, light bulb 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The 7th light bulb all the way through the 18th all endure 69 hours. This 43 says that the 19th through the 43rd midpoint, or the 19th light bulb in the set through the 43rd light bulb, will all be 80 hours. This 61 says that the 44th light bulb through the 61st light bulb will all endure 91 hours. This 75 says that the 62nd midpoint or light bulb through the 75th light bulb will all endure 102 hours. And then this 80 says that the 76th light bulb all the way through the 80th light bulb will all endure 113. So my 40th and 41st data values or midpoints will be here, because this is light bulbs 19 through 43, if you were to list them all out, are both 80 hours. And if you average 80 hours, you add them up and divide by 2, you will receive 80 hours. Now, if you wanted to take the time to list out all 80 midpoints, that would take a long time. It's completely up to you. But the 40th and 41st light bulbs will fall here, and they endure 80 hours approximately. So hence the median is still 80 hours. Now the mode is the data value that occurs most frequently, and in this case it's going to be the midpoint that occurs most frequently. The largest frequency is 25, because I had 25 light bulbs endure about 80 hours, so the mode is 80 hours. And then sometimes they ask you with group data problems to find the modal class, and you will say 74.5 to 85.5 if they ask for the modal class. So for the mode, find the largest frequency if one exists, and refer to either the midpoint if they ask for the mode, and that's 80 hours, or if they ask for the modal class, refer to the class limits of 74.5 to 85.5. Now, last but not least, we have the mid-range. And the mid-range is going to be not the smallest data value, because we don't know it, plus the largest. It's going to be the smallest midpoint of 58 plus the largest midpoint of 113. So you add those together and divide by 2, 85.5 hours. Now I'm going to show you how to put the group data example in the calculator before we move to weighted averages. What you would do in the calculator, go to your Stat button, and if you press Enter, you will see that you already have data from the previous problem, and this is the raw data problem. We wish to clear it out, so I'm going to put my highlighter on the L1. I'm going to press the Clear button and then arrow down. Clear and down. Put your midpoints in the L1 column. Once you are successful, place your frequencies in the L2 column. Again, check and make sure your midpoint column, they are going in the L1 column, and your frequencies are going in the L2 column. So remember, the midpoints represent X, so column L1. And the frequencies represent the F column, the frequency of occurrence, L2. Once you are successful, you will go back to your Stat, arrow over to Calculator, and press Enter. Now my calculator is blinking, asking me where to put the data. Some of the most updated versions of the calculator will actually ask you for the columns in a different way, and I will probably discuss that inside of class. But the way my old TI-83 Plus works, I have to say parentheses, column L1, saying that's where my data values or my midpoints are located in this case, comma, L2. And it has to be in that order for this group data problem. and press enter. Parentheses and comma. And you will see that the 85.1, we did round to the nearest tenth, is the average. You will see that even though it says the summation of X, which represents the sum of all the raw data, the 80 light bulbs, that this is really the summation of all our midpoints, and we got 6,807. S, again, is the standard deviation, and if you scroll down, the median is 80 light bulbs. You will have to find mode and mid-range on your own, but it will give you the mean and the median here for this group data problem. The other type of calculator, the most updated version, when you go over to calculate here, let me do that again. They will ask you where your data is, and then below it they'll ask you where your frequency is. When they ask you where your data is, you will place the L1, call up L1. If they ask you for your frequency list, you will call up L2, and then I believe you press enter. Again, I'll discuss that version of the calculator in the class. If someone would like for me to use your calculator and put it on the document camera in order to show the most updated version of the calculator, I would be glad to do so. So, weighted averages would be the last topic. Weighted averages, again, are different. That is when data values carry different weights. And there is a formula for weighted averages. It is the summation of a column called weight times data divided by the summation of weight. So this is an example in the textbook. Find the weighted mean price of 3 models of automobiles sold. And we have the models A, B, and C, but really we don't even need that column in terms of numbers. We have the numbers sold, 8, 10, and 12, and we have the price of each. They say to find the weighted mean price. That third word is going to be your data column, which is labeled X. And then the other column by default, which has numbers in it, would be your weight column. Always go by the third word, especially if this is not a grade situation, a GPA problem. Weighted mean price, third word is price, so your X goes above price, your W goes above number. Is it very, very, very important not to switch those two around? So then we need weight times data. So 8 times 10,000 is 80,000. 10 times 120,000 is 120,000. 12 times 8,000 is 96,000. And we will add up that column. And the total of each data value times its weight is 296,000. Now you can see the denominator in the formula is the summation of the weights. So if you mislabel, this is the weight column, your denominator here is going to be wrong. Make sure you label the W column as the actual number sold, and we sold 30. So 296,000 divided by 30, if you round to 2 decimal places, and that's because this is money. Even though our raw data values in terms of price are whole numbers, technically the textbook does say to go to 1 additional decimal place, but oftentimes they break that rule when it involves money. So it's 0.67, and that is rounded accurately to 2 decimal places. That's only because it's money that they break the rounding rules stated in the textbook. Here's a grade situation. They are my favorite. Find the weighted average for a student who receives grades of 83, 72, and 90 on a final exam. The exams are 20%, term paper is 30%, and final exam is 50%. And I think I misread that. Find the weighted average for a student who receives grades of 83 on exams, 72 on term paper, and 90 on final. And here are their weights, 20%, 30%, and 50%. This is pretty clear which would be the data column and which would be the weight column. Obviously, the data column is going to be the actual grade, and then the weight column is going to be how much each grade weighs. The exams are 20%, term paper is 30%, and the final is 50%. Now, if you multiply, you will have to change these percentages to decimals. So this would be 0.2, this would be 0.3, and this would be 0.5. So 20% of 83 is 16.6. 0.3 times 72 is 21.6. And 1/2 of 90 is 45. If you add up each grade times its weight, you receive 83.2. And the total of all the weights would be 100%, but we don't use the 100%. We use its decimal answer, which is 1. So 83.2 divided by 1 is 83.2. So this student would receive a B in the class as a final grade. So practice more weighted average problems in your textbook. I've given you a non-grade situation versus a grade situation. And that concludes our lecture on averages. The next Tegrity lecture will concern measures of variation. That lecture is very time consuming, so it will probably be a bit longer than this one. Again, if you struggle, read through the notes, watch the video again. But the examples I show in class are not these examples. They're examples from your homework, your textbook. So I hope you have a blessed day, and I will see you for the next Tegrity lecture. Bye-bye.